Hello, everyone. My name is Konstantinos Costa, and I am a visiting research assistant professor at the University of Pittsburgh. I'm going to present today our work, Thinking Inclusively with CAPRIO, by Lucas Levy, myself, and Panos Chrysanthis. The outline of the presentation is the evolution of CAPRIO. We are going to start with the first approach of CAPRIO, thinking in a selfish way. Then we are going to discuss the mobility constraints added in CAPRIO to overcome some specific problems. Then we are going to discuss the new idea of gathering user preferences and thinking in an inclusive way to create our vision, to implement our vision, and inclusive for all CAPRIO. So CAPRIO started as a simple idea. I came to Pittsburgh from Cyprus in January 2019. The weather in Cyprus in January is like summer, but the weather in Pittsburgh in January is very cold. It's averaging 6 degrees Celsius, so indeed it's very cold. On a regular day at Pitt, I went to the office. I was talking with Panos and I said, I'm very cold. And Panos replied and said, let's do something about it. We are computer scientists. Let's create a system. And so we did. We created CAPRIO, a context-aware path recommendation system that exploits indoor and outdoor information based on a specific situation. It suggests shorter distance paths based on a given departure and arrival time between two locations. But at the same time, it avoids sections that are exposed to the elements due to extreme weather conditions or natural disasters. By using the system, we discovered that not all doors are equal. For example, we are using the system and we found out that one of the doors, it was a one-way door, so we had a problem. At this point, we started to think in a broader way. Different doors are having different characteristics. There are doors with ramps, doors without ramps, and doors that are one way, that are revolving doors, and doors that need special permissions. So in addition of our mobility constraints, the outdoor exposure and the total time limit, we added a new constraint, the accessibility constraint, that allows recommendation of paths that are fully accessible based on the properties of the doors. In 2019, late in 2019, we observed that the indoor paths are not equal anymore due to congested spaces and due to COVID-19 guidelines. We have these delays in the indoor paths. So we added a new constraint, the congestion constraint, that is the maximum congestion allowed for a path. It's a user-defined constraint, and it allows users to specify the tolerances in respect with the exposure of COVID-19. For example, some users are going to wear masks, some users are not going to wear masks. At this point, our system is not inclusive. When people are hearing the inclusivity, they think about disabled people, they think about wheelchair users that are having difficulties in climbing the stairs, or visually impaired people that are struggling with revolving doors. But inclusivity tends to benefit absolutely everyone. For example, think the use and the need of an elevator. If you are a wheelchair user, you need to use the elevator. Or if you are moving heavy objects, again, you need to move the objects using the elevator. Or if you are a caterer and you are moving food across different floors in a specific building, again, you're going to use the elevator. Or even if you are a mother with a stroller, again, they need to use the elevator. So all of these users are benefit from the elevators. So at this point, there is no longer the need of focusing on the individual disabilities, but rather on the individual abilities and the preferences. This means inclusivity for all. So individuals are not disabled. It's the environments that are disabling them. And we want to focus on the user abilities and capabilities. We want to find potential barriers and integrate them as elements of the environments in order to overcome them. Of course, we want to gather information from the user. So there is a good way and a bad way to ask questions. For example, think about a scenario where we want to ask if a user wants to use the elevator. And this is a sensitive matter. So there is the intrusive way, which is, do you have difficulty in climbing the stairs? Or there is a more appropriate way, a comforting way that says, do you prefer to use the stairs, regarding of the limitations of the user? After that, we can give some options to the user. We can give the options of the elevators, ramps, and that goes on. And the user can choose any of these options or all of these options. To implement the system, we are envisioning an architecture of CAPRIO with an inclusive UI, a chatbot, or a virtual client that is asking questions using NLP and machine learning. We want also to integrate the information from IoT devices into our building management system, BMS, in order to have a smarter way to recommend paths. For example, think about an elevator that is broken, or a blocked door, or the cleaning crew is cleaning the toilets. So we can get this information integrated into our system, and based on our constraints, we can find different paths. Of course, this information is going to be an input to our Astro path finding algorithm that optimizes the recommendations based on the number of the preferences and the constraints in order to avoid specific barriers and recommend paths that satisfying all the constraints and the preferences of the user. To conclude, we need to have in mind that inclusivity means algorithmic fairness with no biases for the system, and also for the user interface, we want to have in mind the accessibility and the usability. This is what we are doing in our system as well. Remember that individuals are not disabled, but the environments are disabling them. So gathering this information is the right mechanism to support inclusivity. We want an inclusive system that focuses on the abilities and the comfort and not the limitations of the user. As we already discussed, we want to gather information in a non-intrusive manner. Remember the questions of climbing the stairs. And we believe, based on our experience, that through the context awareness and the personalization with the user preferences, we can achieve a broader inclusivity. Remember that inclusivity benefits everyone, absolutely everyone, regardless of the ability of the user. We are envisioning the new version of CAPRIO, CAPRIO 3.0, to be an inclusive CAPRIO for all. At this point, let me thank you for watching and listening to the presentation, and also let me thank the CAPRIO for All team, Lucas Levy, his guiding dog, and Panos K. Chrysanthis, If you want to learn more about CAPRIO, please visit our website, db.cs.p.edu/CAPRIO, and also visit us at the demos to discuss further information, or if you have any particular ideas and questions, we can discuss.